The topic for this video is circuits. The essential questions are: what is a combination circuit? And how do you calculate the resistance, current, and potential difference in a combination circuit? So in a complex or combination circuits, they're sometimes called both, it's a combination of series and parallel components, and most have that. Like in the diagram, R2 and R3 are in parallel and everything else is in series. So to determine the equivalent resistance for a complex circuit, you have to simplify it and just do it step by step. This is stuff you already know how to do, but it's just putting it into lots of steps back to back. So what we want to find is the equivalent resistance in this circuit. So we've got some in series, some in parallel, so it's a little confusing. So we just have to start at the beginning. So the first thing I'm looking at is the parallel stuff, and inside the parallel we have a series circuit with the 6 ohm and the 2 ohm resistor. So the first thing I'm going to do is simplify that and just add them together, because I know that's what I can do with resistors in series. So their resistance is an equivalent of 8 ohms. And so when I do this, it's a lot easier sometimes, I think, if you redraw it so that you don't get confused about what you've done and what you haven't done. So I'm just going to replace those two with the 8 ohms like it is in the top drawing there. So the next thing I'm going to do is look at these two, which are in parallel, the 8 and the 4. I want to get rid of that parallel circuit. So I'm going to use my parallel resistance equation, and I'm going to put 1 over 8 plus 1 over 4. Remember that you do have to divide out your fractions. You can't just add them like they are. So I got 0.125 plus 0.25, and I get 0.375. I'm going to put that over 1. Sorry, it's a little misplaced there. I'm going to cross multiply, and I'm going to divide. So I get an equivalent resistance of 2.7. So you can see in the drawing I've already replaced 8 and 4 in parallel with a 2.7 resistor in series with the other ones, because that's how they are in the original diagram. Okay, so now I have series. This is the simplest one of all. I can just add those three together to get the equivalent resistance, which is 12.7. So I can redraw this circuit that is really complex with just one resistor in it to represent the total resistance, which is 12.7, and I'm going to put a 9-volt battery on that. So if we want to find the current or potential difference across a particular resistor, we have to do all of that, those steps first to find the equivalent resistance that we just did. Then we have to rebuild the circuit in steps and calculate the current and potential difference for each group. Again, this is stuff you know how to do with series and parallel. It's just putting it together. So we're going to continue the problem we just did. We want to know, the question is going to be, what is the current and potential difference across the 2 ohm resistor? So the first step is to go through all the steps to find the equivalent resistance, which we just did, and that's 12.7 ohms. So if you'll remember, on the circuit diagram we made the battery have a value of 9 volts, and so we're going to have to rebuild the circuit, basically do what we just did backwards. So the first thing I want to do is find the current, and I gave the battery a charge of 9 volts, or the problem gave me that. So I'm going to use Ohm's law and divide, and I get a current running through there of 0.71 amps. So I'm going to use that, so hold on to that number. So the next thing I want to do is take one step back and look at the grouping of resistors that I had added. So I have 9, 2.7, and 1. So they're connected in series, which means the current's the same across all of them, and so that's 0.71 amps. And we only care about the middle resistor in this case because that's going to lead us to the 2 ohm resistor, which is what our question is. If we had to find all the resistors, we'd be doing this for each one. So we're going to use Ohm's law. We can keep the current because series current is the same. And we're going to find the voltage here, so we're going to cross multiply, and we get a voltage going through that 2.7 ohm resistor of 1.9 volts. Okay, so hold on to that number. We're going to use that next. So we're going to separate out the 2.7, and we get an 8 and a 4 in parallel. And if they're in parallel, that means the voltage is the same. So that 1.9 that we just found, we're going to continue to use. And we're only going to focus on the 8 ohm resistor because that's going to lead us to the 2 ohm resistor, which was our question. So I'm going to use Ohm's law. I'm going to use the 1.9 and the 8 for resistance. And I'm going to divide out to get our new current because currents are not the same in parallel. And I divide and I get 0.24 amps. Okay, so I'm going to hold on to that number and use that on the next step. So finally we get to where 8 ohms is going to separate back out into 6 ohms and 2 ohms, and we're going to look at that 2 ohm resistor because that's our question. It means they share the same current, so they have a current of 0.24, which is half of our answer. They wanted to know the current and the potential difference, so we've got our current is 0.24, and we just have to solve for potential difference. So we have 0.24 there. Our resistor is a 2 ohm resistor, and we're looking for V, so we're going to cross multiply. And that gives us a voltage of 0.48. So that is our answer with the current of 0.24 amps.